The Big Bang is about to be thrown into the mud by recent discoveries of the James Webb Space Telescope, or JWST as it is popularly called. This has led to the widespread belief that the Big Bang is a misleading name for our expanding universe. What did the JWST find, and how did it counter the existing theory? You are about to find out, so stay tuned. Before we continue, let's briefly discuss the Big Bang theory. It is the most widely accepted theory for how the universe came to be. The theory states that the universe began with an unimaginably hot and dense single point that expanded and stretched, first at inconceivable rates, then at a more measured pace over the following 13.8 billion years to become the still expanding cosmos we see today. The more traditional Big Bang theories gained root when cosmic expansion abruptly and mysteriously ended. Because current technology does not enable astronomers to directly peek back into the universe's origin, most of what we know about the Big Bang is based on mathematical calculations and models. Astronomers may witness the echo of the expansion via a phenomenon referred to as the cosmic microwave background. Initially, the Big Bang was a simple concept based on three facts placed together. Firstly, according to Einstein's general theory of relativity, a universe populated with any uniform distribution of matter and energy will not be steady in a static configuration, the fabric of space. In that, the universe must either shrink or expand. Secondly, spirals and ellipticals may be seen in the sky extending far beyond the Milky Way, with their distances calculated. Thirdly, the light from these spirals and ellipticals seems to be shifted with more distant objects displaying a larger redshift in direct proportion to their distance. This is compatible with an expanding universe. We may deduce from these three facts that the universe, if it is expanding and getting less dense now, must have been smaller and thicker in the past. We may project this back to very early ages and see that our current universe must have originated from a denser, smaller, more uniform state in the ancient past. Georges Lemaitre was the first to combine this evidence in 1927. However, others would independently arrive at the same conclusion, including Edwin Hubble in 1929, Howard Robertson in 1928, and Arthur Walker a few years later. Although the astronomical community generally accepts the Big Bang hypothesis, some theorists suggest other theories, such as an oscillating universe or an eternal inflation in addition to the Big Bang. This was just before the emergence of NASA's James Webb Telescope, the world's most giant and most powerful infrared space telescope. JWST was launched from ESA's launch facility in Kourou, French Guiana, in 2021. It was designed to explore the universe, to learn about its history, from the Big Bang through exoplanet creation and beyond. As early as July 2022, the JWST was up and running, and NASA unveiled the first scientific photographs from Webb in a live event. Now, these are the surprising JWST discoveries. JWST discovered that there are more galaxies out there than Hubble ever spotted, even at distances Hubble would never be able to detect. Some of these galaxies seem to be more advanced, more massive, and at earlier stages than we had previously seen, as many models and simulations have predicted. However, it observed that JWST's enhanced resolution makes neighboring galaxies look smaller and more compact than Hubble observed. Some of them may even have been huge and developed between 200 and 350 million years after the Big Bang theory. The latest verified record holder from the Hubble was 407 million years after the Big Bang. Many of these galaxies, including the oldest ones, are disc-shaped rather than irregular. This has been shown by JWST's improved imaging and resolving capabilities, even for galaxies that Hubble had previously looked at as erratic blobs. In the JWST version, the individual galaxies shown in the Hubble composite are considerably more well-resolved. This supercomputer simulation sample depicts slightly over 1 million years of cosmic evolution between two converging cold gas streams. In slightly over 100 million years after the occurrence of the Big Bang, clumps of matter developed to form individual stars with solar masses apiece in the densest areas. This might give the first seeds for the universe's most massive black holes and the earliest seeds for the formation of galaxy structures. If done right, this may be a beneficial attitude in science. Solar coronal loops, such as those seen in 2014 by NASA's Solar Dynamics Observatory, follow the course of the Sun's magnetic field. Although the Sun's core may attain temperatures of 15 million Kelvin, the photosphere's edge hovers at a measly 5,700 to 6,000 Kelvin, with colder temperatures found in the photosphere's outermost portions and higher temperatures found closer to the center. MHD, or magnetic hydrodynamics, discusses the interaction of surface magnetic fields with internal processes in stars such as the Sun. Alphen took it a step further when he suggested his plasma cosmology, claiming that gravity may not be the all-essential on cosmic scales, and that magnetic and electric fields and forces were responsible for sculpting the universe. A broad range of observables having a conventional explanation inside the Big Bang paradigm would have to be substituted with a wild alternative in this model of the universe. When Hans Alphen made this suggestion in the middle of the 1960s, the majority of physicists had not even thought of extending the electromagnetic laws to the field of astronomy. Nevertheless, it made sense that electric and magnetic fields may grow significantly given the tremendous energy, vast quantities of charged particles, and dense surroundings. So what exactly does the evidence show? It reveals that if plasma cosmology proponents dare to face their beliefs with observations of the universe itself, things go south quickly. The universe does not fluctuate or cycle between periods of expansion and contraction. It has grown from 380,000 years after the Big Bang, as we have directly measured, to 13.8 million years later. Large transverse velocities might manifest as cosmic rotations at various scales. We have carefully analyzed this, and there are no firm limits on it. They are strong enough to rule out the plasma cosmology model based on these criteria. The resulting cosmic web offers some of the most significant evidence for a universe occupied with cold dark matter in around 5 times the abundance of ordinary matter, generating structures that ideally purge general relativity's predictions in an expanding universe. Plasma cosmology cannot replicate this result quantitatively. No number of hot objects that have cooled down or reflected starlight can create the radiation background. The flawed black bodies that would be added together in the alternative scenario are unable to replicate the cosmic microwave's background perfect black body spectrum. This final finding was enough to disprove Alphen's theory more than a year before he announced it. Plasma cosmology was effectively dead on arrival. It's much simpler to make a dramatic, attention-grabbing assertion than to go through all the facts and reach a reliable, scientifically correct conclusion. The Big Bang also contains many extrapolations, none supported by evidence when the theory was initially suggested and developed. Regardless of our choices, science advances via one and only method, comparing the predictions that our various theories make with the actual real universe that we inhabit. There's no option but to go to the universe for answers on what is truly happening and which explanation is the most accurate. So the Big Bang theory hasn't gone extinct despite common belief. Recent James Webb Telescope observations have not disproved the Big Bang theory. The most recent assertions about Webb destroying the Big Bang theory stem from a famous piece by Eric Lerner. The Hubble observations in 2014 corroborated Lerner's allegation, as do the most recent Webb observations. What Lerner carefully left out of his research is that the Hubble and Webb data supported the LCDM model as well. It's a frequent misconception that redshift demonstrates the galaxies are racing away from us. They're not. Distant galaxies are not traveling at breakneck speed. Space itself is growing, increasing the gap between us. It's a minor distinction, but it implies that the galaxy redshift is generated by cosmic expansion rather than relative motion. It also makes faraway galaxies look bigger than they would in a static world. They are far away and little, yet the extension of space provides the impression that they are more significant. As a consequence, the surface brightness of distant galaxies only decreases proportionally to the redshift. What are your thoughts on the James Webb Telescope and its opinion on the Big Bang theory? Let us know in the comments below. We hope you enjoyed watching this video. If yes, we're sure you would like this next video on here. Thanks for watching and stay tuned for more space videos.